Welcome to the course Mastering JavaScript Design Patterns by Pact Publishing. I am Bumbu and I'm going to present this course. This course is intended for developers who have some experience with JavaScript. You'll need to know some basic concepts such as closures, different ways to invoke a function, and how prototypes work. What is interesting is that most probably you already used or benefited from some design patterns, as most JavaScript libraries use them. Take Bootstrap, AngularJS, or jQuery. In this course, we'll cover over 30 different software design patterns. Many of them are their so-called Gang of 4 design patterns. Other patterns are more specific to dynamic and functional languages. In the first section, we'll make a brief theoretical introduction to what is a design pattern and why they're useful. Also, the definition of anti-pattern will be covered. We'll start with a simple player mock-up looking like this. In the second section, we'll cover some basic patterns and we'll implement a simple logic for playing tracks. In the third section, we'll work on modularizing the application. We'll get from mostly one file application to a set of modules, each with its own responsibility. In the fourth section, we'll work on separation of concerns by using few MVC-based patterns. On visual part, we'll add active track highlight and we'll enable track play button. In the fifth section, we'll be handling different types of tracks and we'll add nested tracks. In the sixth section, we'll build a server that will serve data to our application, so we'll be loading data dynamically. Seventh section will also involve working on server, but this time we'll focus more on front-end communication with the server. We'll load data from multiple sources and we'll use caching. In the last section, we'll focus on some utility patterns that may help to increase code maintainability. Here you can see which patterns are covered in this course. Numbers in parentheses represent subsection numbers where a pattern is used. So, if you want to check a specific pattern where you want to refresh your memory, you can always come back to this table and find the pattern you are interested in. In this section, we're going to cover definitions of software design patterns, anti-patterns, and patterns specifics in JavaScript. Now, we're going to see what are design patterns and what are anti-patterns. So let's start with what is a software design pattern, why design patterns are important, and what is an anti-pattern. A software design pattern is a generic reusable solution to a common problem in software engineering. However, it is not a piece of code that can be directly used. It is more of a description or a template for how to solve a given problem. The same design pattern can be used in multiple programming languages. Even in the same language, one design pattern can be implemented in multiple ways. So, why design patterns are important? Design patterns improve readability and communication with other developers because of use of a common language. They also improve maintainability because design patterns are tested and proven in time solutions. Code reuse is achieved by identifying common solutions to common problems. Design patterns help to design for change, so that when new features will be necessary, it will be easy to implement them. They also help to avoid limitation of implementation language. Not every solution to any problem is a design pattern. There are many debates over what exactly is a design pattern. We'll stick to following simpler rules to check for a pattern. It should solve a generic problem, solution to which is not obvious. It was tested by time, used in multiple projects, and has lots of references. It should be useful, and in our case, it should be applicable to JavaScript. If design patterns are best practices, anti-patterns are bad solutions to common problems. As it is important to know about design patterns, it may be even more important to know about anti-patterns in order to be able to avoid them. Some of the most common anti-patterns in JavaScript are global namespace pollution, using eval incorrectly. Another anti-pattern is modifying default classes prototypes, for example object or array. And in case of browsers, two most common anti-patterns are inline JavaScript and document.write. It is important to know and to be careful with them. Next, we're going to see how patterns are different in dynamic languages and which ECMAScript versions are covered in this course. In the last video, we saw the definition of design pattern and anti-pattern. Now, we'll see how design patterns are different in dynamic languages and which ECMAScript versions are covered in this course. Dynamic languages have fewer language limitations than static languages. Because of this, many common design patterns are not necessary or are much simpler in dynamic languages. Also, dynamic languages encourage new design patterns. For example, in Java, a singleton will require a class with a private variable that will hold the class instance. It is not much code, but in JavaScript, the simple singleton can be written in one line. This is due to the fact that we can instantiate objects without defining classes. And the same is true for many other design patterns. So, if you know a pattern implementation in a static language, you may expect it to be much simpler in JavaScript and in this course. Now, let's take a look at ECMAScript and what versions are covered in this course. ECMAScript is a standardized scripting language. JavaScript is one of its implementations. Despite the fact that it is relatively young, it has lots of implementations. And this is especially important in web applications development, because there are many different browsers widely used, resulting in many different implementations. Different implementations may follow different standard versions or may not have full subset of features described in standard. Even worse, different features may behave differently. This means that even before starting to work on a project, we have to decide on a target audience and to use only those features that will work on all target browsers. This course covers mostly ECMAScript 5 standard, but there are some features from ECMAScript 6 such as generators, promises, ES6 modules, classes. So before using these features, make sure that they match your target audience. If not, then for some features you may use shims that will add missing functionality or transpilers that will compile your code into an ECMAScript 5 compatible code. Let's make a summary of what we've covered in this section. We saw and which patterns are covered in this course. We went through the definition of software design patterns and anti-patterns and why they are important. In the end, we saw how patterns are different in dynamic programming languages and which ECMAScript versions are covered in this course. In the next section, we'll start working on our project and we are going to write actual code. Welcome to section 2, starting the project. In this section, we are going to bootstrap the project and work on improving its structure and modularity. We'll cover some basic patterns, such as module, facade, and adapter pattern. Also, we'll cover some non-standard ways to match conditions. In this video, we are going to initialize our project, create a list of tracks, and render them. During this course, I'm going to use Sublime Text Code Editor and Google Chrome browser. You are free to use any code editor and any browser, but I would recommend latest versions of Google Chrome or Firefox. Now, let's create our folder and add it to the code editor. Here is mine. Inside of it, create a subfolder named Application. We'll place all our front-end code into it. Here I have a gitignore file, because I'm using Git for version control, but you may skip this file. Let's unzip the file provided with this video and add its contents into the application subfolder. You should have the same folder hierarchy as me. For now, script.js is empty. We'll write some code into it in a minute. You can see the bootstrap.css file and some fonts. These are default files that come from Bootstrap bundle. We'll use Bootstrap 3 as a framework for HTML and CSS. We'll use only some basic styles, so there is no need to focus on it. Let's open our index.html file in browser. I am using a local server for that, but opening this file directly in your browser should work as well. I will not focus on writing the HTML. We'll be using the one I prepared for this course. Instead, we'll just inspect few key elements. This is the title of the currently playing track. That's the progress bar. In order to visually update the progress, we have to update the width of the inner progress element. That's our action button. We'll use it to play and pause. And this is our tracks queue. It is basically a table where each row represents a track. Each row has 4 columns. Now we are ready to write some code. But first, let's comment this track. Now our queue is empty. First, we have to create a list of tracks and add few objects into it. As you can see, we define objects using object literal. So, instead of writing new object, we just write curly braces and define object's contents in it. This is a recommended way to define objects in JavaScript. Each track will have an ID, a title, and duration in seconds. As you can see, I'm not using semicolons. This is because in JavaScript they are optional. You just have to know when to use them. If you feel more comfortable, you can use them. But usually this is the decision taken by the team. Just be consistent across the project. Now we'll need a reference to the parent element for our tracks. Here it is in HTML. I'm declaring variables close to the places where they are used, so it is easier to follow the code. But the recommended way is to declare all of them at the top of their scope. In order to render each track, we can simply iterate over our list of tracks. As our parent element is a table, we add child rows using insertRow method. And for creating cells inside a row, we use insertCell method. Don't forget to declare used variables. Now we have rows with empty cells. Let's fill these cells. First cell will contain the ID, second will contain track title, and third will display track duration. Our queue is almost complete. Last thing left is to add track buttons. Each button has a child element that holds a Bootstrap icon. Bootstrap icons are DOM elements that have glyph icon prefixed class. You can check which icons are available in Bootstrap documentation. Buttons can have different sizes and styles. Now we have the Remove button. Let's add the Play button. We'll use the same code with slight changes. Again, don't forget to define new variables. That's it, we created a dynamic list of tracks. In next video, we are going to add play functionality to tracks. In previous video, we rendered the list of tracks. Now, let's add play functionality. But first, we have to fix the anti-pattern we used in previous video. We polluted global namespace. This means that any other script can access the variables we used. This may end up with unexpected behavior or errors. This is easy to fix by encapsulating all our code into immediately invoked function expression. Such a function is invoked immediately after it is defined. And because each function has its own scope, all the variables and functions defined inside such a function will be hidden for the outer world. You can see that tracks is actually pointing now to a DOM element. This is because Google Chrome creates global variables for all DOM elements with IDs. If any library would rely on this feature, then it would not work as expected. because we were changing the value of that variable. Okay, now we don't have any more access to the variables from the outside, so we are less likely to break something. We'll need references to player title, progress bar, and play button DOM elements. Also, we'll need an object that will hold the player state. It will hold current track object, play state, current track progress, and the ID of the interval that updates track progress. We'll update the progress bar using a function that will accept a float value ranging from 0 to 1. 0 meaning no progress, and 1 meaning done. Now let's create a track play function. It will accept a track object as a parameter. If it is the same track and player is playing, then do nothing. If it is a different track, then set it as current and update the progress. Set the state as playing and update the progress bar. Now we'll need an interval that will update track's progress each half of a second. If track still has content, then just update the progress. Else, clear the interval. And play the next track. Let's write the play track function. It will first iterate through the tracks to find the current one. When current track is found, check if there is a next track. If yes, then play it. Let's write the pause track function. It will check if player is playing. If yes, then it will set it as not playing, and it will clear the interval. Then, only thing left is to hook the play button to perform play and pause actions. First, prevent default action on button. Next, if player is playing, pause it, and vice versa. Don't forget to save. And that's it. Now we have a basic play functionality in place. In the next video, we are going to encapsulate information in modules. In last video, we avoided global pollution and added play functionality. In this video, we'll encapsulate information using modules. Also, we'll cover getters and setters. We'll use immediately invoked function expression to hide variables and functions. We only need access to play and pause functionality. So we'll expose these two methods by returning an object. The value of play is a function. Whenever we invoke this function, it will be executed in modules context, thus having access to all inner information. The same is true for pause. Now we just call play whenever we want to play our tracks. Let's play our tracks immediately, when application loads, and pause it after 2 seconds. Let's check the result. Player started and now it stopped. Perfect. Now let's create a module for progress bar. We'll select the DOM element and keep the progress in a variable. That's almost the same function we wrote, but it remembers progress value. And now we return an object that defines a getter and a setter for progress attribute. We don't need this anymore, and this. So, instead of calling setPlayerProgress function, we assign a value to playerProgressBar.progress. Let's check if it's working. Because getters and setters were not supported in Internet Explorer 8 and some other old browsers, many libraries and projects still hesitate using them. In case that we need to support those old browsers, just replace getters and setters with simple attributes set and get. And instead of assigning, we'll just call these methods. Let's check again in browser. Everything looks fine. So, module pattern encapsulates, meaning hides, information from the outer world and exposes an interface that allows accessing only a permitted set of information. This way, we are safe from accidentally rewriting variables. Okay, so in next video, we are going to abstract manipulation of DOM events and elements. In last video, we saw how to encapsulate information and give access only to a limited set of things. In this video, we are going to move all the manipulation with DOM elements and events into a separate file and hide all that complexity using a facade pattern. So, what we want to achieve is a simple API that will allow us to create DOM elements like this. Let's include our new file in index.html. And save it. Now let's create the file. We'll add it to a utils folder. We'll expose a global variable $. Here again is a module. Our first function is create element that accepts element name and some options. Ensure that options are an object. Create the element. If it has a parent, then append our new element to it and return the element. Now let's expose this method as create. Let's check in browser, rows are rendered, so everything is fine. Now let's add our cells. Each cell will have an additional option attribute, which is text. So first cell will contain the ID, second will contain the title, and third will contain the duration. We have to process this new option attribute. Let's write it as a new function, as we'll have more options later. Again, options should be an object. If we have text, then call setTextElement, which is another function. For modern browsers, we'll use text content, which should be faster. But for those that don't support this functionality, we'll use inner HTML. Now we can check it again. Okay. Now the buttons. Here we'll use class name as options attribute. You can see that code becomes more compact and easier to read. We don't need this anymore. So if options.className is available, then set the class name attribute. We are done with DOM elements. Now let's proceed to events. We'll handle all three types of event declaration. Add event listener for supported by newer browsers, and attach event or an event for older browsers. And we'll do the same for event listener removal. This way, we'll handle browsers' compatibility complexity in this module, and we'll expose just two simple methods. Let's use our new methods to listen for events. And the final check in browser. Okay, so facade pattern is about hiding the underlying complexity behind an interface. For example, in case of DOM events, we hid the complexity of checking how browser allows to subscribe and unsubscribe from events. Now, this code should work in both old and modern browsers. Before that, it would work only in browsers that supported add event listener. Next, we're going to create an adapter to set intervals using seconds. In previous video, we used a facade to hide the complexity of manipulating with DOM events and elements. Now, let's create an adapter for set timeout and set interval functions. We'll need a new file for that, so let's create timer.js. This time, we don't need a module, as we don't have hidden data. We'll use an object literal. The idea is to make it easier to read code by specifying interval and timeout delay in seconds, and as a first argument. Let's use these methods in code. Now, whenever you read the code, you see the delay from the beginning. You don't have to search for the end of the function. Adapter is often used as a converter between two incompatible interfaces. For example, when you set opacity using jQuery and the browser doesn't support opacity CSS attribute, then jQuery uses filter attribute. This way, it adapts to browser's interface. In our case, we adapted set timeout and set interval to be easier to use them. In next video, we are going to explore few ways to match conditions. In last video, we implemented a simple adapter for set timeout and set interval. In this video, we are going to see how we can use object and array literals to match conditions. So, first, let's create an object. This object will have as keys element names and as values functions that, when invoked, will create elements of given type. These functions will accept one optional argument, which is the parent element. In case of text element, we could create an element with empty string, but we'll use this dummy text. And last, a universal elements creator. We actually use the same technique in createElement function, so we could just use this function for creating table rows and columns. But we'll leave them for the sake of this example. So if we have a function for a given type of element, we create the element using that function. Otherwise, just fall back to universal function. And this is not necessary anymore. Let's check it, and it works. Now, let's see a similar example but with arrays. If you know that you have to match a value of a variable by a set of sequential numbers, then you can create an array with values being equal to expected result. Just return the values stored at array index. You could check for array length if passed argument can be bigger than number of elements. These two techniques may help you organize the code when you have if or switch statements with many conditions. This was the last video of section 2, which we started with bootstrapping the project and avoiding global pollution. Then we encapsulated information using modules. Then we hid complexity of DOM events and elements manipulation using facade pattern. The last two videos were about adapting an API and using different methods for condition matching. In next section, we are going to review different methods that will help us keep our application modular. Hi, and welcome to section 3. We'll start this section with a simple module system based on namespaces. Then, we'll review and switch to AMD modules. We'll use a pub/sub pattern for communication between modules. In the end, we'll review the new ES6 modules syntax. As you saw in previous section, our application grew quite a bit, and it starts to be hard to remember all the things each file can do. So, we're going to split the application into multiple files, and we'll use the namespace pattern for keeping references to each file. First, let's add an index file. It will contain our singleton object. If it was already defined, then assign it to itself. meaning that nothing changes. And if it wasn't defined, then define it as an empty object. Now let's define one more index, but this time in utils folder. We also define an object, but this time it is an attribute of our singleton. Now let's change how dom.js file is defined. So instead of exposing $d as a global variable, we just set it as an attribute of player.js.utils. The same goes for timer.js. So basically that's the idea of namespace pattern. You keep all the dependencies as attributes of an object, and this object may have nested objects. This way you expose one single global variable. Let's start splitting that big script.js file. First, we'll create the queue folder. As usual, first file is index.js. Next, we'll create a collection module that will keep the list of tracks. We'll take the list from here and we'll move it here. Now, let's move tracks rendering into a separate module. We use the module pattern so that inner details of the module stay hidden. Here, we'll need tracks list and DOM manipulation module. That's basically how we access modules. We'll put this into a function so that tracks are rendered not when module is defined, but when this function will be called. Now let's add player modules. First, we define index.js. Let's move the progress into a separate file. Here it is easy as we just copy-paste it. And now the controller. Again, we copy-paste it into the file. Only that here we'll need the references to player progress bar and tracks list. Also, we have to update references to timer and $d variables. Okay, now we are left with our main file. First, we render the track list. Then we make our player to play. And after 2 seconds, we stop the player. Let's check it in browser, and it works. Now our application is modular, but there are some downsides with this implementation. So in next video, we're going to see what are these downsides and how we can overcome them. In previous video, we used namespace pattern to split application into modules. So in this video, we're going to use a more suitable module definition for browsers, AMD, which stands for Asynchronous Module Definition. As a module loader, we'll use required.js. So which downsides had a namespace pattern and what does solve AMD? Using AMD, we don't have any more to define modules as global variables. You can specify the dependencies of each module, so that when you require a module, first its dependencies are resolved, and only then module's factory function is called. Also, you don't have to define multiple files in a specific order in your HTML. You just define one script that will do all the job. So, first thing, it is to download the required.js file. I will download the one with comments. Okay, we can remove all these script declarations and add this one. It will load the required.js that will call script.js, but not before it will resolve all its dependencies. We don't need any more index.js files, so let's remove them all. Each file should contain one module. You define a module using a define function that takes two arguments, an array of dependencies and a factory function. Factory function will get as arguments resolved dependency modules that can be used right away. We replace our global variables with function arguments. In case that a module has no dependencies, then we just specify an empty dependency list. Let's move this into a function that will return this object upon execution. We don't need self-invoking function anymore, because require.js will call this function when the module is requested, but after all the dependencies are resolved. Again, we replace global variables with scoped variables. This one is straightforward. Our progress module has no significant changes. The controller depends on player progress, queue collection, utils DOM and utils timer. We remove the global variable definitions and replace them with function arguments. Okay, so finally we are done with this. Check in browser, great. Let's see how dependencies are resolved. First, the browser loads a require file, which loads script file. Script.js has three dependencies: collection view, controller, and timer. So these three files are loaded in browser. But some of these files also have dependencies. Collection view has collection and DOM files as dependencies, so the browser loads them next. Also, the controller has some dependencies. These are progress, collection, DOM, and timer. Progress file is loaded, but all the other dependencies are served from cache because they were requested earlier. And only after all the dependencies are resolved, the script.js factory function is executed. You can find more information on the require.js website. Pay attention to circular dependencies, as people often fall in this trap. In next video, we are going to see how to implement a communication mechanism between modules. In previous video, we used AMD modules to keep our application modular. But now it becomes quite challenging to pass messages between modules. So in this video, we're going to use a pub/sub pattern, also known as observer. But first, let's display the player state in action button, so that when the player is playing, action button shows a play icon, and when player is paused, action button shows a pause icon. In set button state, we first remove both possible class names and then add glyph icon play or pause class name. So when player is playing, we set the button state as playing and vice versa. We use two new methods that are not defined in our DOM module, so let's add them. When we want to add a class name, we split class name attribute, check if given class is present in the list, and if not, we add it and update the class name attribute with a new set of classes. And we do basically the same for remove class. Now we have to expose these two methods. Good, now let's check in browser. As you can see, now our button shows the player state. Okay, now let's proceed to our pub/sub module. The name pub/sub comes from abbreviation of publish and subscribe. The whole idea is that we have an object that exposes two methods, publish and subscribe. In our case, we'll name them trigger and on, as in jQuery and many other libraries. We'll also provide an unsubscribe method called off. Now, when a module wants to pass a message to other modules, it calls trigger method by specifying a channel name and some arguments. And any module that subscribes to that channel will receive that message. In order to subscribe to messages, a module has to call on method and to provide a channel name, a function to be called when messages are available, and a context to run the function in. Last argument is optional. It may sound confusing, so let's trigger some messages. Whenever player plays a song, we'll trigger a message in player play channel and we'll pass additionally the track object. Whenever the player is paused, we'll trigger a message in play pause channel. Now any other module can subscribe to these channels, and whenever a message is triggered, listening modules may react. We'll create a state message in header that will display both the state of the player and currently playing track. For that, we'll need a new module, header view. We'll need references to the state HTML element and also to text and icon elements. Whenever a player play message will be triggered, we'll display the state element. We'll also update the text with track title and we'll set the icon as playing. And whenever a play pause message will be triggered, we'll change the icon from playing to paused. Let's add these two new DOM methods that we used, text and display. As text function is already defined, we just have to expose it. Display function will simply update the style.display attribute of element. Passing a null value to this function will enable the display property specified in CSS, Fanny. If we will check in browser now, then we'll see no changes as header view module was never required. We'll fix this by requiring it in main file. We'll not use module instance, all we need is its factory method to be called. Now we should be good to go. Whenever we play and pause, the header status is updated accordingly. And the nice part here is that we can remove the header view module or plug it in whenever we want, and nothing will break because our modules are now loosely coupled. In next video, we'll review new module syntax introduced in ECMAScript 6. In previous video, we used a pub/sub for communication between modules. Now let's try the new ES6 modules. But first, you have to know that this is a new specification. Actually, it's been around for some time, but its final version appeared recently. That's why currently there are no browsers that support this feature. But luckily, there are a few transpilers that allow us to write a subset of ES6 features that can be transformed to ES5 compatible code. One of such transpilers is babel.js. It supports many ES6 features, but will use only the modules. Because we already have a required JS in place, we'll use it as our module loading system. First, we'll need to install required JS Babel. But for that, you'll need npm already installed. If you don't have npm, then go to npmjs.com and check in documentation how to install it. Also, we'll need to add a package.json file. This file will contain metadata about the project, such as name, version, description, and dependencies. When installing a npm module, its name is saved in this file. So, when you'll want to work or execute your project on another machine, you'll know what are the dependencies for this project. Okay, now we can install required JS Babel. We add the -- save so that the package.json gets updated. Here it is. Next, we have to add required JS configuration. Usually this is done in a separate file, but I will put it in script.js. Update the paths so that the browser will be able to find the files. And let's check if file version is the correct one. Nope. Copy and put it here. Now let's create an ES6 module. Basically, a file that exports something is a module. We can define a default export. Importing such a module will return default export, which is in our case a log function. Let's create another module and import our log module. We can set any name for the default export. I will call it log. Let's add a now variable and export another function. This function will use log function to console log the value of now. In order to require an ES6 module in require.js, we have to prepend its name with ES6 exclamation mark. The rest is the same as with AMD modules. So timer.logTime should log the now variable value. Here it is. We can actually have multiple exports. Let's export now variable. This is called named exports. Let's check if it's working. Yep. Let's add one more named export, but this time in log module. It will be quite a similar function, but it will prepend the timestamp to the output. In order to load a named export, we wrap its name in curly braces, and then just use it as a normal function. So, log date will show the timestamp and Monday. If it's Monday for you, then you should feel lucky. And here it is in browser. There are more interesting things in ES6 modules. I recommend starting with this article on duality.com. ES6 modules will definitely change how we define and use modules in JavaScript world. There is one more popular module system in JavaScript community, CommonJS. It is mostly used on the server side, for example Node.js. But in last years, it saw a boost with the help of such tools as Browserify. We'll cover CommonJS modules in section 6 when we'll be building our server. We started this section with a simple module system based on namespaces. Then we switched to AMD and require.js. After that, we saw how we can implement an easy communication between modules. And in the end, we checked the new module system introduced in ES6. In the next section, we are going to work on application organization through separation of concerns. In this section, we'll be organizing our application through separation of concerns. We'll start this section by decoupling tracks queue from tracks player. Next, we are going to treat each track as a separate component. After that, we'll add pub/sub functionality to each track model. In last 3 videos, we'll review and implement MVC, MVP, and MVVM patterns. And we'll start with decoupling tracks queue from tracks player, so that they will act as 2 separate modules. These 2 modules will use pub/sub for communication. Also, we'll use a configuration object to initialize the queue controller. But first, let's add some spacing between tracks buttons. Let's disable browser files cache for tabs with open developer tools. Okay, now our buttons look much better. We have to move tracks management into queue files. So we'll create a queue controller. It will have access to tracks collection and it will know which track is active. Also, it will render tracks collection. We'll use configuration object pattern. This meaning that the queue controller will have a set of default options. If we instantiate a queue controller without options, then default options will be used. If we'll pass an object with options, then these options will be applied over default options. By default, current track index is -1, meaning that there is no current track. Now initialize hooks, which we'll write in a minute. If autoload is active, then load data on controller initialization. If auto-render is active, then render tracks on controller initialization. If autoplay is active and we have tracks, then trigger a message that will request the player to play first track. Let's write the needHooks function. Whenever player will trigger a play message, we'll check for the track and we'll update current index. We update current index like this because we can trigger a message that will request the player to play a track, but it may not be available or it may refuse to do so. That's why we update current index only when player acknowledges us that it's playing a track. Another hook will listen for requests to play next track. Such a message can be sent by the player when it finishes playing a track or by any other module that is interested in playing next track. For now, loadData function will just assign tracks collection to collection attribute. Render function will call tracksView.render with tracks collection as an argument. This way, tracksView will not depend on tracks collection anymore. And the only module responsible for tracks collection will be the queueController. Let's update player controller by removing tracks collection dependency. playNextTrack function simply requests the queue to play next track. Clicking on player button checks if we have a current track. If yes, then play it. Else, request the queue to play next track. Instead of calling this controller directly, we'll trigger messages that will request player to play or to pause. The last file that has to be updated is script.js. We'll need an instance to queueController. Even if we don't use directly player controller anymore, it still has to be initialized, just as header view. Let's increase the pause delay to 3 seconds. Okay, let's see if it still works. Nice. In next video, we'll start working towards MVC pattern by treating each track as a separate component. In previous video, we decoupled tracks queue from tracks player. In this video, we'll go further and we'll create a component for each track. Each component will be composed from a controller, a modal, and a view. You may recognize the MVC pattern. The truth is that this video is just the base for MVC. We'll get to the classical MVC pattern in next 3 videos. So first, let's create tracks folder. We'll start with the controller. In MVC, controller is the entry point to a component. It instantiates and knows about modal and view. So in our case, when we want to render the track, we ask the controller to do so. And controller knows how and to whom to delegate that. Now the modal. Modal is an entity that knows how to store data. When we access or update some attributes, the modal may make a database or HTTP request to get or update data in persistent storage. In our case, we'll just keep the data as attributes of an object. We need a function that will return just an object with data. Has method will check if modal has defined an attribute, and get will return an attribute value. If a non-existent attribute is accessed, then we could just raise an exception, but we'll just return a null. We'll return a function that when called will create an object whose prototype will be a track model object. This is prototypal inheritance. We use the new utils method, utils.clone. So let's go and create it. It's simply copy-pasting attributes of one object into another. We need a clone function because objects in JavaScript are passed as references. And if we are going to update an attribute of a past object, then it will be updated everywhere. And we don't want that for our models. Now let's proceed with track view. In MVC, view is responsible for visual representation of data. In our case, it is responsible for rendering DOM elements. We'll have a render function that will be basically the same function that we used in collection view. We'll copy the tracks container. We'll add a class name whose value will depend on modal being active or not. We'll use this functionality later. Now copy-paste cells creation. We can safely remove these variables as we didn't use them. And now render buttons. Again, this is mostly a copy-paste from old function. Okay, now as we're done with our track component pieces, let's move forward and update our application to use these new objects. First, we're going to update the collection list. Instead of storing plain objects, we'll be storing track controllers. Also, we have to update the way QController uses collection elements. As player is expecting an object, we'll call model.json to obtain this object. And instead of accessing an attribute directly, we'll use model.get. Let's store a reference to the view so we don't create it multiple times. Now collection view. As we moved almost everything to track view, we can safely remove what's left. Now, track view will be a function so that a reference to its instance could be kept. Rendering is quite straightforward, as all we have to do is to iterate through all the tracks controllers and ask them to render. Okay, let's check in browser. And we have an error. Let's see. Oh. So we didn't update track references in track view. Let's do it now. Instead of tracks at index I, we'll use this.model.get. And save, and check. Great, now it's working. As we mentioned prototypal inheritance, let's see what is that and how it works. In JavaScript, each object has an internal link to another object called prototype. That object also has its own prototype object, and so on until an object with null prototype is reached. Now, what for are these prototypes? When you access a property of an object, this property, let's say a method, is first searched among these object properties, then among its prototype object properties, and so on until the property is found or until a null prototype is reached. In order to set an object as the prototype of another object, you use object.create. Let's see how it works. We'll set a breakpoint in QCollection. Here we have all the tracks. We are interested in modules. Let's review how modules are created. When you want to create a module, object.create is called with track module as an argument. After that, we call init method to initialize the module. So we have here an object with only one property, attributes. This property was created by init method, but still we can call module.getTitle. Module has no such property, so this property is looked up in its prototype object. The prototype object has such a method, so it gets executed. Let's call model toString. Our object has no such property, and its prototype object doesn't. But the prototype of prototype object has this property. This is actually the object that is used as a default prototype for almost all JavaScript objects. If we try accessing a dummy text property, then we will get undefined, as such a property wasn't found in prototype chain. If you are interested in more information about this topic, then you can start with this MDN article. Okay, so next we're going to continue working on MVC and we'll add pub/sub functionality to tracks. In previous video, we started treating each track as a separate component. In this video, we'll add pub/sub functionality to each track. To achieve that, we'll use pub/sub as a mixin. First, we have to create a pub/sub mixin file. We'll copy the contents of pub/sub into it. We'll add a init method that will initialize observer's empty object. We'll need a destroy method that will free these observers. And we'll move ensure topic exists into object attributes. The main idea in mixin pattern is that one object can borrow the functionality of another object. For that, pub/sub/mixin has to return an object with all its functionality inside of it. We have to update all the references to observer's object and to ensure topic exists function. In order to use the mixin, we simply create a new object with pub/sub/mixin as a prototype and call init method so that observer's object is initialized. And we do the same for track module. The only difference here is that we call pub/sub/mixin.init method as track module has its own init method. Okay, these changes shouldn't break anything, but just in case, let's check in browser. So, the idea in mixin pattern is that you have an object in which you store specific functionality. In our case, we put the pub/sub functionality inside of a mixin. And you add these properties to the objects where you need the functionality. And about the pub/sub, it can be found as a core feature in many JavaScript libraries and frameworks. For example, in Ember.js, evented class is also a mixin. In Backbone, events are used to notify about all entities' lifecycle, be it collection, model, or view. In next video, we are going to enable track play button and we'll highlight active track. Also, we'll have a complete MVC pattern. In previous video, we added pub/sub functionality to modules. Now, we are going to highlight active tracks. Also, we'll enable track play button. In the end, we'll have a fully implemented MVC pattern. We'll need a set method for track modules. This will allow updating module attributes and triggering an update event. Then, in track controller, we're going to listen for global events. Whenever a player play event will be triggered, we'll check for the track ID. If the ID is similar to module's ID, then we set this track as active. Otherwise, we set this module as not active. Now the module. Let's save the reference to controller and let's initialize a row attribute. We'll listen for module events and whenever module changes, we'll render the view. As render function will be called multiple times, we have to check if it's first render or not. If it is not the first render, then we create a new row and replace the old row with the new one. If it is first render, then we just create a new row. We have to update references to row. In the end, set it as rendered. Let's check in browser. Active track should be highlighted, and when a new track becomes active, previous active track should fade. Great, it works. Now, let's enable track play button. For that, we'll need a controller method that will proxy view requests. And in the view, when play button is clicked, we'll call controller's method with play as an argument. Last piece is the queue controller that will listen for request queue play message. We'll check if such a track exists in queue, and if yes, then it will request player to play the track. Each time model.toJSON is called, a new object is created. That's why we have to update player controller to check for track similarity not by reference, but by ID. Because now tracks may be played out of sequence, we have to take care about interval and progress. Let's check if clicking track play button will work. And another one. Yep. Let's review MVC pattern. MVC has three main parts: a module that holds data, a view that is responsible for visual part, and a controller that processes view events. Whenever something happens in view, it passes a message to controller. Controller decides what to do with that message, often resulting in module update. And when module is updated, the view receives an update message through pub/sub. It is considered that Backbone.js implements the MVC. From my point of view, Backbone implements the MVP pattern, but we'll cover that in next video. Actually, most JavaScript frameworks implement a flavor of MVC, but not the classical MVC. There is one framework that claims to implement the real Smalltalk MVC. It is Mariah. That's the framework that implements the MVC pattern most closely to the classical one. This classical MVC topic is a never-ending debate, so we'll stop here. But if you want to get more in depth with this topic, I would recommend Martin Fowler's article. It covers MVC, MVP, and some other related patterns. In next video, we're going to decouple track module from track view. Also, we'll cover MVP pattern. In previous video, we implemented the MVC pattern. In this video, we are going to implement the MVP pattern, which is quite similar to MVC, but its main difference is that the view does not have direct access to the module. So, we don't pass anymore the module and the controller references into view. Instead, we'll pass an interface through each the view will communicate with controller. View's render method will get an object that will contain the data that should be rendered. Now, the controller is responsible for rendering the view when module changes. Let's update the view. We don't have any more access to module and controller, only to an interface. We can't listen anymore to module events, so let's remove this functionality. As we get the rendered data as an argument, let's use it. When an event happens, we inform the controller through the interface. Let's check. OK. So, in MVP, we have the same module and view as in MVC, but instead of controller, we have a presenter. The presenter knows about the view. However, the view knows only about an interface that it may use to notify presenter about different events. The presenter also knows about the module, so it is responsible for communication between view and module. Now, as we know about MVC and MVP, we can discuss why Backbone.js implements a pattern that resembles more MVP than MVC. A Backbone module can be considered as a MVP module. A Backbone view template can be considered as a MVP view, because it just shows data to user. And a Backbone view can be considered as a MVP controller, because it knows about module and template. It can process all the view events, and it can subscribe to module changes and update the template accordingly. And that's actually how things most often are done in Backbone applications. But it is not limited to that, so you could do it other way. And then it will be a different pattern. In the same way, AngularJS can be treated as a framework that allows MVP implementation. But let's conclude this video with a library that explicitly states that it implements strict MVP pattern. It is first version of Riot.js. Don't confuse it with second version. This is a minimalist library built around few very simple ideas. I would recommend checking it out. In next video, we are going to review MVVM pattern, and we'll implement two-way data binding. In previous video, we implemented MVP pattern. In this video, we'll implement MVVM pattern. To exemplify its usage, we'll format track time and we'll add two-way data binding. MVVM is similar to MVP, but here VM part is responsible not only for communication between module and view, but also for data formatting. So, before passing render data into view, we'll first format it as we need it. In our case, we'll change track duration format. Now we can see track duration in a more natural way. Next, we'll add ability to update track title. For that, we'll need a flag in order to know if we are in edit mode. We'll not render the whole row anymore. Instead, we'll update row class and title if row was already rendered. If it wasn't rendered, then we do the same we did before, only the title is rendered separately. The title can have two states, display and edit. For display, we'll use a span. For edit, we'll use an input and a button. When the title is in edit mode, then the span is hidden. Otherwise, the input and the button are hidden. Whenever we click on span, the title is switched to edit mode. Whenever we click on button, the title is switched to view mode. And whenever we type something into input, the controller gets notified about that. We have to update setTextToElement method as it will not work with input elements. This is quite simple, as in case of text input, the only thing we have to do is to update value attribute. Now the controller. Every time we'll type in input, it will get notified about that. In such cases, we'll update the model with a new title. Let's see how it works. We update the title, and when we play it, the new title is used. As we saw, the MVVM pattern is very similar to MVP, only instead of presenter we have a view model. The main difference is that before passing data to the view model formats the data. Some frameworks claim to implement MVVM pattern. Knockout.js is one of them. You can see that it has a view model entity built into framework. Another framework that also has a view model entity is Vue.js. And thinking through, you can say that MVVM can be easily implemented in Backbone and Angular. MVVM can also be referenced as MVVP or Presentation Model. This is a really interesting article from Martin Fowler, who seems to be among the first to describe this pattern. This was the last video of this section. We started this section by using a configuration object. In second video, we used prototypal inheritance. In third video, we added pub/sub functionality to tracks models by using mixin pattern. In last three videos, we implemented and reviewed MVC, MVP, and MVVM patterns. In next section, we are going to focus more on tracks functionality, such as nested tracks and tracks iteration. In this section, we'll enhance tracks functionality and we'll add nested tracks. We'll start this section by adding few types of tracks and lazy initialization. After that, we'll add ability to remove tracks and we'll implement methods chaining. In third and fourth videos, we'll implement tracks iteration using a generator and an iterator. In last two videos, we'll add nested tracks and we'll implement mixins, but in a different way than in previous section. So, in this video, we'll add a few types of tracks and we'll use factory pattern to initialize them. Also, we'll implement lazy initialization. First, we'll rename the model into model track and we'll return the track model object. We'll do that so it will become possible to add other types of tracks that will use track model as a prototype. One such type is single model. It will be the same as track model, but the toJSON method we'll generate a title that will contain track year and name attributes. Also, we'll create an album module. Here again, we'll alter the title into JSON method, but in this case, it will contain album year, album title, and name. Now the factory. The factory is a module that will accept a track type and track data. Based on track type, it will create a corresponding object. This way, we don't have to know about the constructors and how to call them. We can just use the factory. And whenever we need to change how a module is initialized, we do that just in one place. Let's pass tracks types to already defined tracks. Also, let's define two new tracks, one single track and one album. Okay, now the last piece, track controller. Instead of track module, we'll use the module factory, to which we'll pass both track type and track data. Let's see our new tracks. Great. Now, lazy initialization. It is a simple pattern that can save lots of resources. The idea is to initialize data only when it's required. In our case, we were initializing track controllers right when collection module was loaded. But we can defer tracks creation until application explicitly asks for that. Lazy initialization is just the tip of the iceberg. There is much more with lazy evaluation. You can check lazy.js to see how it works. Lazy evaluation was also added to Lodash, and this is a nice article explaining how it works. So I recommend checking them out. In next video, we are going to implement track removal. In previous video, we added multiple types of tracks. In this video, we'll implement track removal. As each track has an event listener, we'll have to remove those too. Also, in case when an active track will be removed, we'll activate the next available track. In the end, we'll add methods chaining. So first, we'll listen for remove button click. And when that happens, we'll notify the controller about that. Whenever the controller receives a remove message, it will ask the queue to remove the track. We'll add a track removal request to the queue controller, but first, let's add a utility function that will help us getting an index of a track. We add this function as this same thing is implemented multiple times in this controller. Let's update the player play listener. Also, let's update the request queue play listener. Okay, now we can proceed to writing the listener for queue remove listener. First, we get the track index. Then, we call a controller destroy method. After that, we remove the controller from the collection. If it was the active track, then play the track with the same index, or the last one if active track was the last one in the queue. Else, if it was a track preceding current track, then we have to update the index of current track. We used a new request message, so let's add it. Request queue index listener will play a track by its index in collection, if it's available. Now, let's define track destroy method. But first, we have to save the reference to player play event listener. On track destroy, we ask view to destroy and we unhook the player play event listener. That's why we have to save a reference to that function. Track view will simply remove the parent element from DOM. Okay, let's check. Remove this, remove the active track, good. Now let's implement one very simple but handy pattern. Methods chaining. Its idea is very simple. First, all chainable methods should return a reference to the instance. After that, we can call these methods in chain. For example, here we write pub/sub variable only at the beginning, and then just call the on methods in chain. This example may look strange if you are not used to this syntax, but basically it is the same as writing it like this. If you ever used jQuery, then most probably you are familiar with this pattern. For example here, first the element's color will be set as red, then a slide up will happen, and then the slide down. And the benefit is that because we call the methods in chain, we don't need a variable to store the reference to the jQuery element. In next video, we'll iterate over tracks using a generator. In previous video, we implemented methods chaining. In this video, we are going to iterate through tracks using a generator. In order to create a generator object, we'll need a generator function. This is a new technology that is part of ES6 standard. In order to define a generator function, we use function keyword followed by an asterisk. Calling such a function will return a generator object. That object has a next method that, when called, returns current generator value as long as it has values. But how does generator know about which value is the current one? That's where yield keyword enters the game. Every time we call next method, generator function resumes its execution from last yield. And as long as generator function yields, generator object will have a return value. Okay, so let's implement that. We'll get rid of lazy initialization for now. We'll define track iterator, which is a generator function. This function will keep track of current index. And as long as current index is smaller than the number of available tracks, will yield a track. This module will return a function that, when executed, will create a new generator. Now the controller. We don't need any more current index here. If autoplay is active, then ask the queue to play next track, which will be the first track. This is obsolete. Also this one. Because we don't have direct access to tracks collection, requesting queue to play a specific track will not work for now. Requesting to play next track is simply checking if next track is available, and if yes, then playing it. Requesting to play a track by an index will also not work for now. The collection will link to a generator. Now we'll pass the generator object directly into viewRender method. Last file to be updated is collection view. Track view is now just an empty function. Render method will render tracks as long as they are available. Let's check if it's working. Great. Using a generator for iteration is just the tip of the iceberg. There is much more that can be done with generators, such as lazy initialization or multitasking. I recommend reading this article on duality.com that covers generators in detail. In next video, we are going to iterate through tracks using an iterator. In previous video, we used generators for iterating through tracks. In this video, we'll be using iterators for the same purpose. Also, we'll fix what we broke in previous video. As of ES6, there is an iterator protocol. In fact, a generator is an iterator. Here again, we see the next method, the same we used in previous video. So, in order for an object to be an iterator, we have to implement this method, as specified in this protocol. Let's update our tracks collection. We'll define a tracks iterator function that will implement iterator protocol. Also, we'll add few other methods that will make using the iterator much easier. As next, we'll return true if there are iterable values left. Next, we'll increment internal current index and we'll return an object as per protocol. Actually, current method will implement the protocol, but it was handy to use it in next method. Reset method will reset the internal index counter and will allow restarting the iteration. We'll also add a remove by ID method. It will remove the track that will match given ID. But this method may be unsafe to use, as all the iterators use a reference to the same collection of tracks. In our case it's safe, as after first render there is only one iterator used. The module will return a function, which will return a new iterator object when called. Because a generator is also an iterator, our application already should work. Let's check it. Yep. But let's fix those things that we broke in previous video. Whenever we want to play a specific track, we can simply reset the iterator and iterate through it until we find the desired track. We'll not request the queue to play a track by index, so we can remove this listener. On remove request, we'll first check if the track that should be removed is the current track, and if yes, we'll request the next track. Only after that, we'll remove current track. Oh, we can rewrite the request queue next handler to make use of new methods. Okay, let's see if it works. Play, remove, great. It may be odd to use iterators instead of a simple array, but this will be handy in next video where we'll add nested tracks. In previous video, we iterated over tracks using an iterator. In this video, we'll add nested tracks. First, let's define an array that will keep all child tracks and set the default nesting level. Adding a child track is simply updating its nesting level and adding it to the list of child tracks. Nesting level will be used to add a padding to nested tracks. If this would be not necessary, we could not add nesting level. Basically, we implemented a composite pattern because now each track may act as a parent track that has child tracks. When a track is rendered, we'll render its child tracks, if any. We have to check for duration, as we'll not add duration to parent tracks. Okay, so let's go and add some child tracks. Fifth track will be an album and will have no title and duration. Sixth track will be a child of fifth track. Seventh track will be an album and a child of fifth track. Eighth track will be a seventh track child. Okay, let's see how it looks. Everything fine except album titles have an undefined. This is because our albums don't have a name anymore. Now it's much better. Now let's add some padding to nested tracks. This CSS will add a greater than sign to the left of nested tracks. We'll render the nestedness in view's render method. Render nested level will add the padded class name to the track and will add a padding depending on nesting level. We used $.css method, which was not defined before, so let's add it now. This will simply update the DOM element style object with given style name and style value. Let's see how it looks now. Great. Now we can see which tracks are nested. So the idea in composite pattern is that an object can be a parent and a child in the same time. It can be a parent for other similar objects, and it can be a child for another parent object. There is one problem though. Remove and play functionality doesn't work right. So in next video we are going to fix that. In previous video we added nested tracks. In this video we are going to make playing and removing nested tracks work. And we'll start with an iterator mixin. As a base, we'll use the iterator we defined earlier. We'll use the iterator as a mixin because we'll mix it with main tracks collection and with each track. And we don't want to write the same code in two places. We'll store child tracks as an object argument. Also, we'll need a method to add child tracks. The iterator will work in following way. First, it will return a child track. After that, it will check if that track has any child tracks of its own and will return them. When a child track has no more children to return, then the iterator will proceed with its next child track until it iterates through all of them. This is a depth-first traversal. Next method will check if there are any next tracks, and if yes, it will check if next track is its own child or a nested child. Depending on that, it will return its own child or a nested child. Current method will also check if current track is this iterator child or a nested child. Depending on that, it will return its own child or a nested child. In order for a set method to work as expected, it has to reset all child iterators recursively. Also, remove by ID method has to search recursively. Okay, now let's go and add these iterator methods to tracks collection. We'll define tracks iterator as a function, and we'll add iterator methods to its prototype. This way, we'll make use of prototypal inheritance. Instead of tracks.push, we have to use now tracksCollection.addChild. And we'll return the tracks collection object. Let's go and add util.makesFromTo method that we used in iterator mixin. This will do the same thing as clone method, but here we'll be copying attributes into the past object. Because we didn't add any duration to track albums, we don't want them to be played. So we'll mark all tracks as playable except album tracks. We'll have to rewrite album model init function to be able to do so. Now we'll add iterator functionality to tracks controllers so that we'll be able to add as many nested levels as we need to. We'll call init method in track controller constructor function, and we'll add iterator methods to its prototype. Here I comment that this method rewrites an iterator method. We don't render child tracks this way anymore. But on destroy, we have to ensure that child tracks are also destroyed. Let's check in player controller if a track is playable, and if not, we'll just ask the queue for the next track. Last thing is, we have to reset the iterator after the tracks are rendered, because we use the same instance of iterator for both rendering and playing. Let's see if custom track play and remove work. Great. Okay, this was the last video of this section, which we started with adding few types of tracks. Then we added tracks lazy initialization. After that, we added ability to remove tracks. In fourth video, we used methods chaining. In fifth and sixth videos, we implemented tracks iteration using a generator and an iterator. In last two videos, we added nested tracks. In next section, we'll build a server and we'll use it as a data provider. In this section, we'll build the server and we'll load data from it. We'll start this section by creating a simple server using Node.js. Next, we'll return tracks queue from server. In third video, we'll load tracks data from server. After that, we'll use a promise instead of a callback. In last video, we'll use proxy pattern to bind functions to custom contexts. So let's proceed to server building. But first, we'll need Node.js and npm applications installed. Actually, this should be already installed, as in fourth video of section 3, we used npm. But just in case, if you skip that video, then you can install them now. Also, we'll use Express module. This is one of the most popular web frameworks for Node.js, and it's fairly easy to use. Let's check if package.json got updated. Yep. You may have a different version here, and it's fine, as these modules get often updated. Now the server. We'll create a new folder for that. For now, all the code will be contained in server.js file. We'll require Express module and we'll create a new server instance. All the files from application folder will be served as static files. A GET request to tracks root will return an array with 2 objects. These are just some random objects to test if everything is working. Now we make the server to listen for requests on port 3000. Starting the server is as simple as running server/server.js script with Node.js. Now we can check in browser if it's working. It should be available on localhost 3000. Because we told the server that everything in application folder should be returned as it is, we can see our web page. Now, if we open /tracks, then we can see a JSON object with our tracks. In next video, we'll implement returning tracks queue from server, taking in account nested tracks. In previous video, we created the server. In this video, we'll make it return queue tracks, including child tracks. First, we'll create collection class file. It will contain the tracks collection constructor function. We'll store tracks as key values of an object and as a list. In list, we'll store all tracks except child tracks. We'll use add method for adding tracks to the collection. First, we'll check if a track has a parent ID attribute and if such a parent exists. If yes, then we'll ensure that parent track has a tracks attribute and we'll add this track as a child to that parent track. If this track has no parent track, then we'll simply add it to the tracks list. After that, all tracks are added to the key value store. getTracks3 will simply return tracks list. In the end, we'll export tracks collection function. The module.export is part of CommonJS module definition. Here, we used loose inequality instead of strict inequality, so that it will match against null and undefined. Now we'll create the collection. In order to load a CommonJS module, we simply call a require function. Because CommonJS modules are synchronous, we don't have to use callbacks as in AMD. Let's copy the list of tracks from our front-end application. We'll add track type as an argument to all album and single tracks. This way, we'll assume that track's default type is track. We'll use tracksCollection.add to add tracks to the collection. In order to mark child tracks, we'll set parent ID attributes. This module will return an object with getTracks3 attribute. Now the last thing to do is to update server.js file. We'll require tracks collection module and we'll return tracks3 from the server's get request. Let's start the server and check how it's working. If you didn't stop the server from previous video, then you'll have to restart it. Stopping the server is done using Ctrl+C keyboard shortcut. Okay, so here we have all the tracks, and fifth tracks has few child tracks. Let's review CommonJS modules and compare them with AMD and ES6 modules. CommonJS modules use exports or module.export for exposing the module's interface. In order to load a module, require function is used. Require is a synchronous function, so it will first load the module and only after that it will go further. On the other hand, AMD is asynchronous, and you have to declare all the dependencies beforehand. Also, you have to take care of returning an interface from factory function. ES6 modules are supposed to have the benefits of AMD and CommonJS modules, but currently modules loader API is still a work in progress. But it should support both asynchronous and synchronous module loading, compact syntax and cyclic dependencies. Until then, use what better fits your needs. In next video, we'll load these tracks in our front-end application. In previous video, we made server to return tracks list. In this video, we'll load these tracks into our front-end application. We'll remove built-in tracks from queueCollection and we'll add loadFrom method. It will accept a URL and a callback. We need a callback because we'll retrieve tracks from the server using XML HTTP request, which is asynchronous. In onload method, we'll check for the response status, and if it is 200, then we'll initialize the modules and we'll call the callback. We'll use an error first callback, which means that first argument passed into callback will be an error. If a request is successful, then we'll pass a null as first argument. Now let's write the add objects as modules function that we just used. It will accept as arguments a list of objects and a parent track. These objects will be used to create track modules and added as children to parent track. We'll get a reference to child tracks of an object and we'll remove them from the object, as we don't want track modules to have such an attribute. If a track has child tracks, then we'll call add objects as modules recursively. Now the queue controller. Load data method will require a callback. This method will first wait for load data to return a result, and only after that the callback will be fired. And in case of an error, we'll show it in console. Because render and playing depend on tracks data, we'll call this only after data is loaded. One last thing is to call the render method with a write context. Okay, let's see. Don't forget that the server should be started. Here are the tracks loaded from server. Great. We used error first callback. This is a convention used in many projects, and most notably in Node.js. It makes using it very simple, as you know that a callback will always get as first argument an error and as second argument successful response data. In next video, we'll review another way to handle asynchronous operations by using promises. In previous video, we loaded data from server and used an error first callback. In this video, we'll replace this callback with a promise. Promises are objects that hold a state of asynchronous or synchronous computation. Instead of calling a callback when computation is done, we call resolve and reject functions. Resolve for success and reject for an error. Load from method will return this promise. Also, the load data method will return the promise. And now the best part. Promises have a then method that accepts a callback that is called when a promise is resolved. So first, the console log will fire. Then the render, and then the pub/sub trigger. Also, promises have a catch method. A function passed to catch method will be called if instead of resolve, the reject function will be called, or if an error happens in any function passed to then method. Let's see in browser. Everything works fine and the data was logged into console. Promises have much more functionality and there are a lot of other use cases. I recommend checking this article on MDN to see what other functionality is covered by promises. In next video, we'll use proxy pattern to bind functions to custom contexts. In previous video, we used a promise. In this video, we'll use a proxy pattern to bind functions to custom contexts. We'll create a proxy method in util module. It will make use of JavaScript apply method. Apply method allows calling a function with a custom context. Now we can get rid of that variables that we used. Just wrap the function in util.proxy and pass a context as a second argument. Let's do the same in track view. Actually, there is an easier way to bind a context to a function. Starting with ES 5.1, functions have a bind method. And we used it in track controller like this. A final check if everything works fine. Nice. This was the last video of this section, which we started by creating a simple server using Node.js. Then we returned tracks queue from server. In third video, we loaded tracks data from server. After that, we used a promise instead of an error first callback. And in this video, we used proxy pattern to bind functions to custom contexts. In next section, we'll load tracks from multiple sources. In this section, we'll load tracks additional data and we'll work with it. We'll start this section by loading tracks additional data. Next, we'll add caching to these requests. In third video, we'll add fallback mechanisms to data loading. In last video, we'll decrease application memory footprint by using shared objects for common data. So, in this video, we'll add a way to retrieve secondary data for each track from server, and we'll render that data on track play. We'll use free images. You can find them in images.zip file provided with this video. There is also a 1 pixel empty image. We'll use it as a placeholder. First, we'll have to add a way to load additional data for each track. We'll create a getById method in collection class. We'll return original year and cover attributes, computed based on track ID. Each fourth track will not have any cover. We'll return the collection instance as we'll use the same methods the collection has. Now, when server receives a GET request at track/track ID, then it asks the collection for the track with such an ID. If the track is found, then it is returned as JSON object. And if not, then a 404 HTTP response is returned. Let's start the server and see how it works. So track with ID 0, we don't have such a track. Track with ID 1, good. ID 2, perfect. Okay, now the application. We'll add this CSS so that it will be possible to display a cover image inside of play block. We'll also need this HTML code, and we'll also display track original year. Now let's go and create a module that will perform the data loading. GetTrackData will accept a track object and will perform a request to the server. We'll use again promises. So if everything is fine, then the promise is resolved, and if not, then the promise is rejected. We'll ask for additional track data from player controller. It is considered a bad practice to update the view from controller. A better approach is to use MV patterns, as in section 4. And we'll fix that in next section using a similar approach. We'll need references to original year, cover block and cover image DOM elements. When a track is first time played, then we'll render its additional data. Rendering additional data will ask for track additional data and will update the original year and cover. In case of an error, then we'll empty these visual elements. Setting the original year will remove the hide class and will update the DOM element text. If original year value is null, then its DOM element will be hidden. The same with the cover. Cover block will get visible by removing hide class. And image source attribute will be updated. In case that the data is not available, then the cover block will get hidden. We use the $.attr method, so let's add it. It will simply update the element attribute value. Okay, now we can test it. And we forgot to add a comma. Here it is. Now it works. So we have different images for different tracks, and the year is updated. If there is no image, then nothing is shown. In next video, we'll implement data caching. In previous video, we loaded tracks additional data from server. In this video, we are going to cache server responses. We'll use memoization pattern for that. We'll use a plain JavaScript object as a cache store. Now, before making a request, we'll first check if the data for given track is available. And if yes, we'll resolve the promise immediately. Otherwise, we'll make a server request. And when server will respond, we'll store its response into our cache. Okay, let's see it in action. This is first request, and second, and third. Play first again and no request. Play fourth and there is a new request. Great. Here we used memoization for caching network requests. But it can be used for any function that returns a response based on past arguments. This pattern can be easily implemented in existing projects. For example, by using a library such as memoize. It allows wrapping functions and returning a new function that supports memoization. But there is one caveat here, and it is a famous one. If your data can change over time, then you have to ensure that cached data is the right one. One way to partially solve that would be to keep cache only for a few minutes. Other would be to subscribe to server updates. But it all depends on requirements and overall system architecture. In next video, we'll check for track data with a fallback in case of an error, or if server will become unavailable. In previous video, we cached data from server responses. In this video, we'll implement chain of responsibility. We'll implement a fallback system for tracks data. We'll create and use three data providers: cache, server, and fallback. First, getTrackData function will try to get the data from cache. If it will fail, then it will try to get the data from server. In case of success, it will store the data in cache. If the server request will fail, then we'll use the fallback provider. We'll reuse this part of code in server data provider, so we'll copy it. And remove this. Now the server data provider. It's almost the same code that we used in first video of this section. We'll return a promise that will resolve when data is available and will fail if data is not available. To keep the API simple, we'll return an object with a get method. Now the cache. It will be basically the same thing we added in previous video. We'll use here a promise so that all data providers return promises. This module will export an object with both a get and a set methods. Now the fallback. Again, it will create a promise object. Fallback data provider will try to infer track data from original year attribute, album year attribute, and year attribute. In case that no one of these attributes is available, then no year value will be set. As a cover, the cover/fallback.jpg image will be used. This module will export an object with just a get method. We'll update the server so that the track with ID 3 will result in an error. Let's start the server. First track had no cache. And second track also had no cache. Cache is working. Accessing data for third track resulted in a not found request, and the fallback data provider set the year and the cover. Perfect. Let's review chain of responsibility. Its main idea is that you have a chain of handlers that can handle data, and you try them one by one until one of them handles the data. In next video, we'll use flyweight pattern to store common tracks data in shared objects. In previous video, we used a fallback mechanism for tracks data retrieval. In this video, we'll implement flyweight pattern that helps reducing application memory usage by sharing common data between objects. In tracks cache, we'll store unique objects in a plain object, and common data will be stored in an array. In order to retrieve tracks data, we'll clone it. We'll copy all the attributes from common object and we'll remove the link to common object. Adding a track to cache will require splitting a track's data into unique and common parts. A reference to common data object will be stored in common attributes. getCommonData object will check if an object with the same data is already stored. If yes, then it will be returned. Otherwise, it will be stored in common objects cache. getCommon and unique parts will simply split the object into the common part that will contain only the original year and cover attributes, and the unique part that will contain all the other attributes. We used util.equal, so let's go and add it. It will iterate first for all the attributes of first object and will check if second object has such an attribute, and if values of these objects are equal. Then the same process will be done but for the second object. This way will ensure that all attributes of both objects are covered. Now let's check if it worked. First, we'll play all the tracks so that we'll have more tracks in cache. Now we'll need to see the internal state of the module. We can do that by setting a breakpoint in track data cache module, in a place that we know that it will be called. Nice. Tracks cache unique has 5 objects, and tracks cache common has 3 objects, which means that 2 objects got reused. This was the last video of this section, which we started by loading tracks additional data. Then we added caching. In third video, we added fallback mechanisms to data loading. In this video, we decreased application memory footprint by using shared objects for common data. In next section, we'll improve code maintainability. In this section, we'll use few techniques for improving code maintainability. We'll start this section by using template method pattern. Next, we'll implement inversion of control by using dependency injection. After that, we'll use live post-processing for checking arguments types. In last video, we'll enable tracks modules to support any string as attribute name. So, in this video, we'll create a base object for player's header view. Then, we'll extend it and we'll implement those methods that affect how the view behaves. Also, we'll use duck typing for inferring track type. We'll add this CSS to Jumbotron class so that setting a background to this element will make it cover the whole element. Now, let's create the player header view base object. We'll create a hero view plain object. We'll add 4 attributes that will be references to DOM elements. They will be original year, cover image, and Jumbotron elements. Next, we'll create the show method that will delegate to show original year and set cover. These 2 methods, show original year and set cover, will be empty. Adding logic to these methods will be the task of subclassed objects. One of subclassed objects will be hero track view. Hero track view will use base object as a prototype, but it will rewrite show original year method so that if original year is available, then it will be shown. Otherwise, the DOM element will be hidden. Also, the setCover method is rewritten. It will first reset the background of Jumbotron element, as it may be set by the module that we'll add next. If the cover value is available, then it will be used as cover image. Otherwise, cover element will be hidden. Now we'll create a player header view for single tracks. Hero single view object will be created using base class as a prototype. That's the same thing we did in previous module. Also, the show original year method will be almost the same. We'll just add the single word. The setCover method will add a background image to Jumbotron if cover value is available. It will also hide the cover block. Okay, now we can use these objects. First, we'll require heroes track and single views. We'll remove these DOM elements as we'll not use them anymore. Now, when track data will become available, we'll use duck typing to detect if a track is of single type, and we'll call the matching view. In case of an error, we'll just call HeroTrackView.show method with a null argument. We'll move the fourth track into second position so that second track will be a single track. Let's start the server and see how it works. Playing second track sets a background image to the whole player header. Playing other tracks will remove that background and will show the cover image. So, the idea in template method is that a base object implements a skeleton of an algorithm in a method. This is template method, and it defers some or all steps to subclasses. In our case, we subclassed in Hero Single View and Hero Track View. In next video, we'll improve code testability by using inversion of control. In previous video, we used template method. In this video, we'll create an injector module that will allow requiring dependencies only when a function is called. So first, let's create injector module. It will create a wrapper function that when called will first resolve function dependencies, and only after that it will execute the original function. The main idea here is that the dependencies are not required by the module, but the other way around. The injector module is responsible for resolving the dependencies required by a function, and after it does it, it injects these dependencies by passing them as arguments. This may seem to be the same as AMD modules. The difference is that when running tests, we can configure injector module in such a way that it will inject custom objects. This will allow true unit testing without the burden of many nested dependencies. Now, in player controller, we don't need any more these dependencies. We just have to update the function creation by using injector.resolve method and passing required dependencies. These dependencies will be injected as function arguments. Let's check if it works. Great. One of the most known libraries for dependency injection is AngularJS. It allows 3 different ways to declare dependencies. And in one of them, dependencies are read from function argument names. Other 2 methods require explicitly specifying the dependencies. In next video, we'll use live post-processing for checking arguments types. In previous video, we implemented inversion of control. In this video, we'll use live post-processing for checking arguments types. We'll add a injector.validate method. It will make use of function-to-string method that returns the body of a function as a string. This will allow us to parse it using a regular expression and extract arguments names and comments provided with these arguments. We'll see how it looks like in a minute. Now, when we have arguments names and comments attached to them, we can check for arguments values types before the function will be invoked. In case that an argument has a different type than the one specified in comment, will raise an error. In the end, we'll call the original function. Now, instead of simply creating a function, we wrap it in injector.validate method. State should be of type string and active should be of type boolean. Let's pass second argument into setPlayButton function as true. It will do nothing, but if we don't set it, then an error will be thrown. Okay, we have an error when the track is stopped and the button state should be updated. Let's also add second argument here. Let's see if it will trigger an error this time. Great. Now let's try to set a number. And it tries an error. How about an object? The same. Maybe a string. Again an error. Great. Live post-processing may be used for any type of arguments validation, tracking, or even arguments updating. There is one problem though. If you'll use minification, then, depending on your minifier settings, the comments most probably will be gone. A solution for that would be to keep the comments, or to define a specific format for these comments and leave only those that are useful. For example, in Uglify.js, you can specify a regular expression to check if it should keep specific comments. Another solution would be not to check for arguments on production. This should be easy to do if you'll replace the validator function on production so that it will not check for comments. Also, it will improve the code performance. In next video, we'll enable tracks modules to support any string as attribute name. In previous video, we used live post processing for checking arguments types. In this video, we'll enable tracks modules to support any string as attribute name. So first, let's see what's the problem. Let's get access to a track module instance. For that, we'll set a breakpoint in module track file. Great. So now, we can check if module has a isPlayable attribute. Yes, it has. But if we add a new attribute with name hasOwnProperty and a random value, for example false, then the model will not work anymore. This is because we overrided hasOwnProperty function, which we were using to check for attributes presence. We can overcome this by checking for an attribute using in construction like this. Let's check if it will work. This is true, setting an attribute. This is still true, great. But now we have another problem. The prototype attribute is returned as present. This may turn in a major problem. There are solutions for both problems. In first case, we can use hasOwnProperty of object prototype, thus being safe from hasOwnProperty overriding. Other solution is to use a dictionary object, an object without a prototype. We create such an object using object.create with a null prototype, and then we just copy the data attributes. Or you can use both solutions and be safer from unexpected JavaScript engine behaviors. Also, we'll have to update the utils clone method not to rely on past object prototype. This was the last video of this section that we started with template method pattern. Then we implemented inversion of control by using dependency injection. In third video, we used live post processing for checking arguments types. And in this video, we enabled tracks modules to support any string as attribute name. This was also the last section of this course. If you are interested in more information, then I recommend checking these websites. Mozilla Developer Network has a lot of references to JavaScript features that are covered with many examples. You can find a lot of good articles about different design patterns on Martin Fowler's website. Duality.com has a lot of information about JavaScript design patterns, different interpreters features, and different ECMAScript features in much detail. And the best way to learn is through example. A good source of examples are major JavaScript frameworks, such as Backbone, Angular, Ember, or Redux. Such frameworks often push the limit of JavaScript and bring life to new ideas. Also, you can find my contacts and some articles about design patterns on my website. Thank you so much for watching the entire course. I hope you did enjoy this course at least as much as I did. And also, I hope that you learned many useful things that will help you build more maintainable, reliable, and efficient code. Goodbye and good luck.